our topic is fundamental principle of counting. Before going into the permutations and combinations concept, here this is a basic concept to learn. Let's see what's that. Fundamental principle of counting. The first one is multiplication principle. First, let's go through the question, then we'll go through the statement here. Mohan has 3 pants and 2 shirts. How many different pairs of a pant and a shirt can he dress up with? There's a person called Mohan and he's got 3 pants and 2 shirts, right? In how many ways can he arrange them? Mohan has to select 1 pant from given 3 pants. That can be done in 3 ways. Multiplied by, he can select 1 shirt from the given 2 shirts in 2 ways. So the total will be 6. So in 6 ways, he can dress up choosing a different pant and a shirt, right? So this will be your answer. Now, going to the statement. If an event can occur in m different ways. So here the first event is selecting 1 pant from 3 different pants. So the first one is m. Here m value is nothing but 3. Next, following which another event can occur in n different ways. So here this event should occur and the next event should also occur. Now n is an event of selecting 1 shirt from 2 different shirts. So here the value of n will be 2, which will be equal to product of m and n. That is what we did here, product of 3 by 2, which will be equal to 6. Going through the traditional method now. Okay. Now, Mohan has 3 pants, right? So, I'll name those pants as P1, P2 and P3. He's got 2 shirts now. That will be S1, S2, S1, S2, S1, S2. So, what are the different arrangements we have? Pant 1 goes with shirt 1. Pant 1 goes with second shirt. Pant 2 goes with shirt 1. Pant 2 goes with shirt 2. Pant 3 with S1. Pant 3 with S2. So, if we count these arrangements, how many do we have? 6. So, this is a traditional method. But by using multiplication principle, we can give the answer in a one-liner. M by n by p, right? Where m is the event of selecting 1 pant from 3 pants. N is an event of selecting 1 shirt from 2 shirts. So, in total, 6 will be your answer. The next question. Shabnam has 2 school bags, 3 tiffin boxes and 2 water bottles. In how many ways can she carry these items choosing 1 each? Going through the multiplication principle, he can select 1 school bag from 2 school bags in 2 different ways. Multiplied by, why are we multiplying? Because he should carry a school bag and a tiffin box and a water bottle, right? So, whenever we are having the condition as and, we will go with multiplication symbol. Got it? So, the next one, he should carry 1 tiffin box from 3 tiffin boxes, right? So, that can be done in 3 ways. And whenever we get and, it should be multiplied. So, multiplication symbol and he should select 1 water bottle from 2 water bottles. That can be done in 2 ways. So, what is the answer? 2 multiplied by 3 is 6. 6 multiplied by 2 is 12. So, in 12 ways, he can carry 1 school bag, 1 tiffin box and 1 water bottle in different arrangements. This is the simplest way to answer this question. What is the traditional way? Let's see. Now, I'll name the school bags as B1, B2. B1, B2. Now, I'll name the tiffin boxes as T1, T2, T3. So, B1 can go with T1. This can go with T2, this can go with T3. Similarly, second bag can go with T1, T2, T3 tiffin box. Then we need to select water bottle, right? So, we have 2 water bottles, W1, W2. W1, W2. W1, W2. W1, W2. W1, W2. W1, W2. So if we count the arrangements here, we have 12 arrangements. B1, T1, W1, B1, T1, W2. This is first. This is second arrangement. This is third arrangement. This will be fourth arrangement. This will be fifth arrangement. This will be sixth. This will be seventh. This is eighth. This will be ninth. This will be 10th. This will be 11th. This will be 12th. In 12 different ways, he can carry one school bag, one tiffin box and one water bottle in different arrangements, right? So, 12 will be answer. An alternative to this is only the multiplication principle. We are just going to multiply the evens given here. 2 by 3 by 2, which is 2 3s are 6, 6 2s are 12. The next question, find the number of 4-letter words with or without meaning which can be formed out of the letters of the word rose, R-O-S-E, rose, where the repetition of the letters is not allowed. Here, the key words are repetition of the letters is not allowed, okay, and with or without meaning. That means we can form words even without meaning, okay. Repetition is not allowed. Once you write a letter R, the next time R shouldn't be repeated. That is the concept here. We need to form 4-letter words. So, I'll go with 4 blanks. And we have 4 letters, right? R-O-S-E are the letters that we have. The first blank can be filled in 4 ways. We can select either R, O, S or E, right? So, this blank can go in 4 ways. Here, we should form 4-letter words, right? So, this should be there, this should be there, this one and this one should be there. We are going with the condition and, right? So, whenever and is there, we need to multiply, right? So, we are left only with 3 letters now. So, the next blank can be filled in 3 different ways. And the third blank can be filled with 2 different letters. So, we are already done with 3 letters, right? We have only 1 letter more here, which can be filled in 1 way. So, multiplying these values, we get the answer. 4 3s are 12, 12 2s are 24, 24 1s are 24. So, if we try to form different 4-letter words from the given letters R-O-S-E, we get 24 different arrangements. That is your answer. The next question. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that repetition of the digits is allowed? Let's see the first one here. Repetition of the digits is allowed. So, we have to form 3-digit numbers. I'll go with 3 blanks, right? This should be filled and second blank should be filled and third blank should be filled. So, whenever we have and, we need to go with multiplication, right? Now, how many digits are given for us? 5 digits. 1, 2, 3, 4, 5. The first blank can be filled in 5 different ways. So, 5 different ways. Here, the case is repetition is allowed. So, in case if I use 1 here, I can also use 1 here because repetition is allowed. I can use 1 here also because repetition is allowed. In this case, the second blank can also be filled in 5 different ways. The third blank can also be filled in 5 different ways because repetition is allowed. And we have 5 numbers, right? So, 5 5s are 25, 25 5s are 125. So, 125 3-digit numbers can be formed using the digits 1, 2, 3, 4 and 5. The next question, repetition of the digits is not allowed. So, same, we have 3 blanks. We are going with multiplication principle because we have a condition and this should be filled and this, right? So, for the first blank, we have 5 options 1, 2, 3, 4, 5, any of the 5 numbers. So, it can be filled with any of the 5 numbers. Because repetition is not allowed, for 1 digit is already over, we have only 4 digits left with us. The second blank can be filled in 4 different ways. Now, 2 blanks are over, right? We have only 1 blank left. We have 3 numbers left. So, the next blank can be filled in 3 different ways. The multiplication of all these 3 will be your answer. 5 4s are 5 4s are 20, 23s are 60. So, hope you understood the difference of repetition here. If the repetition is allowed, the same number can go here, here and here, right? If the repetition is not allowed, the digit should not be repeated, right? So, if the repetition is allowed, we have 5 by 5 by 5, which is 125. If the repetition is not allowed, 5 by 4 by 3, 60 ways. That is 60 numbers can be formed. This is based on multiplication principle. The next concept is addition principle. Let's go with the question first. There are 25 students in a class with 15 boys and 10 girls. The class teacher selects either a boy or a girl for monitor post of the class. In how many ways the class teacher can make this selection? Now, what is given? We have 15 boys, right, and 10 girls. The teacher has to select only one class leader for the whole class. That can be either a boy or a girl. So, firstly, I'll try to select a boy from the given 15 boys. That can be done in 15 ways. 15 ways. Or, what is the keyword here? Either a boy or a girl. We have or. Whenever we have or condition, we should go with plus symbol. That is addition. We can select one girl from 10 girls in 10 ways. So, what will be our answer? 25. In 25 ways, the teacher can select either a boy or a girl for the monitor post. Right? Here the keyword is or. Whenever we have or, we'll go with addition symbol plus. Now we'll go to the addition principle statement. If there are n different jobs, each of which can be performed in mi ways, then the total number of ways of performing all the things simultaneously is m1 plus m2 plus m3 plus so on. Here the jobs are mutually exclusive. The first one can be selected in m1 ways. That is, m1 is the event of selecting a boy from 15 boys. That is 15. M2 is an event of selecting one girl from 10 girls. So, this will be M2. What is the addition principle? M1 plus M2, which is 25. The next question. A college offers 6 courses in the morning and 4 in the evening. Find the number of ways a student can select exactly one course either in the morning or in the evening. What is the keyword here? Or. Whenever we have or in the question, we should blindly go with addition principle. Firstly, a student can select any one course from the morning sessions, right? So, that can be done in 6 ways. Or the student can select any one course from the evening courses, right? So, or is there, we'll go with plus symbol, and any one from the 4 courses can be done in 4 ways, which will be equal to 10. So, in 10 different ways, the student can select a course either in the morning or in the evening. In total, 10 different ways. Let's see the difference between multiplication principle and addition principle through this question. The question goes here. A person wants to go from station P to station Q. There are 4 routes from P to Q and 5 routes from Q to R. In how many ways can he travel from P to R? There's a station P here. Okay, now, there are 4 routes from P to Q. There is one more station Q here. How many routes do we have here? We have 4 different routes to go from P to Q. Next. And 5 routes from Q to R. There is another station R. And from Q to R, we have 5 routes. 1, 2, 3, 4, 5. Right. So, what is the question here? In how many ways can he travel from P to R? So, he can go from following the first route P to Q and the first route under QR. So, different combinations we have here. So, what is that we need to do? He should go from P to Q and Q to R. What is the keyword we are getting here? And. To reach R station, P has to go to Q and then come to R. We are getting the keyword and here. So, whenever we have and, it comes under multiplication principle. He can select any one route from the 4 routes in 4 ways. and multiplication. He can select one root from the 5 roots in 5 ways. So 4 multiplied by 5 is 20. In 20 ways he can reach from P to R. Right? So he should go to Q and only then he can go to R. So we are getting the keyword and that goes with multiplication principle. Let's see what we get under addition principle. A person wants to leave station Q. There are 4 routes from station Q to P and 5 routes from Q to R. In how many ways can he travel from the station Q? Right? Now we have a station Q here. There are 4 routes from Q to P. There is another station P. From Q to P, we have 4 routes. And 5 routes from Q to R. We have another station R. And we have 5 routes. Right. In how many ways can he travel from the station Q? From station Q, he can go to station P. In how many ways? 4 ways. 4. Or from station Q, he can go to station R in 5 ways. So, or, whenever we get or, we should go with addition. So, 4 plus 5 which is equal to 9 ways. What is the question here? How many ways can he travel from station Q? He can travel from station Q to P, right? Or he can travel from Q to R, right? So Q to P, he has 4 choices. So he can select any one from that. And from Q to R, he has 5 choices. He can select any one. Because the keyword is or, we are going with addition principle. Now, the basic difference here is whenever we have and, whenever we have a and condition in the question, we go with multiplication of the events. Whenever we have or as the condition, we go with addition. We go with addition of the events. So this is a main keyword here and the basic difference. Whenever we get and in the question, we should go with multiplication. Whenever we have a choice, that is to select either this or that, whenever we have or, we go with addition principle. Thank you.